my best for last. We at the end managed. We are JADS, and we are going to present our safety monitor, the crime story. So I'd like to first begin with a question. How are crimes like a storm? Before we answer that, I'd like to present our team. We're over here. I am Diego. I am the police chief officer of the JADS Academy, and I came with my other officers. And we have a problem that we cannot be assigned to the Chicago city area. We want to be assigned ideally in a way that we can cover where the crimes are happening and do a better patrolling of the whole city. So our question is really, how can we assign each other efficiently to the city? So what we want to do is go from stable to dynamic hotspots. So we can take a snapshot of where crime is happening across the city. So you can see there's statistics all over the web. But these are quite stable statistics. So we want to go towards more, what is that dynamic movement? And I think you might get an idea here of how crime is like a storm. So we would like to show you a demo of what we've done in the past 24 hours. So we basically have an application that has 3 parts. The first part is a map. The second part is a bar graph, and the third one is a timeline. So I'm going to go through it a bit. So you can scroll through the map and just go in general. This is nice because you can see from out and from in. You can, of course, select the type of the crime that you are interested in. So once your view is fixed on a place, you see how these crimes are relating to each other. So right now here we are on crime time. We might want to see how well are we doing at that particular spot. So if we had any arrests at that place, we will see that those were the arrests of the crime families. So that was the first part, the crime part. Then we can have a location description. So the interesting part about here is that the police not only would know where to go, but also what to look for. So for example, these are street crimes, apartment crimes, residence crimes. And the idea is that we give this information to not only deploy the police task there, but also, look at the streets. There, depending on the crime also, some things will happen more than others. Finally, and this is the one I like the most, and this is where you can applaud, we can see how these clouds are moving around the city. So this is time index, and this is today. So we can plot whatever happened before today. And of course, the interesting part of weather is the forecasting. So right here, we're seeing that forecasted data of how we see those little clouds moving. So I'd like to go with whatever time I have left into a little bit more detail about the actual model. So this is our predictive model, very high level. I don't want to talk much about it, but basically it captures 2 things. One is the part of the general crime that it already happens in that city. And you can see it up here. It's basically that kernel that is generating those crimes that regularly happen. But this is the interesting part, how we enter to predict crime based on other features. And the idea is that this is extendable, and we would include more or less features, and we do it on a logistic regression. And there's more details about the variables if you want them. So basically, final remarks. We can add more functionality to this dashboard, of course. The idea is that it's easy to use and that it's actionable. We want to enrich the prediction model with external data sets like Twitter and stuff that we have seen before. We want to validate this by randomized field trials. So the idea is that not only we know that we are policing better, but how better are we policing? So the idea is, have controlled experiments where you see, is it really helping that we are standing there and preventing crime by being just there? Right now, we see it as complete and ready to use. You can plug also the data of some other city. We try to find some Dutch data, but really, first of all, it's not so easy. Second of all, we don't speak Dutch, so understanding the crimes will be a little more difficult. And right now the project is on GitHub, so we would like to also share with you guys, and if you want to fork it, if you want to use it, if you want to, in the future. And this is our little prediction.
You have 7 seconds. Okay.
Any questions?
Ah, great. I'm really curious, how does this go beyond the current systems that are already in place to solve these kind of...
I think there's always a bleeding edge of data science, and you see that always new techniques are being used. So it might be that techniques are being used, of course, to try to deploy. But when I see those field experiments, like we need to try, let's see what different models will, if they do better than the ones that we already have. We also want to go towards a more advanced analytics type of setting in which you can do it online, in which you have your own personalized dashboards for policemen, etc.
What's the data that you use?
We use the Chicago data.
The scientific police data.
Yes.
And because I saw also the weather component, demography, and did you actually use that as well?
Yes, so what we did, if I can say it very quickly, we divided the city of Chicago into a grid, and then we calculate values for each point of the grid, and then we use it to estimate the probability that a crime happens in that point of the grid.
And how well does it work? How well does it predict?
The rock curve is right here.
Okay.
This is very good performance.
It's, I get to admit it's not because of the weather. The weather is not very good at that.
Somebody?
Great. I would like to ask the jury to go backstage and make your decision.